Hi everyone, this is Julius S. Almasin from Section R, then Group 1. Today I'm going to give some example problem regarding sa topic na minimum edge distance. So example problem number 1. A bolted bearing type connection shown in figure 3.11, so kani silang duha, consists of 16 mm by 150 mm steel plates with 22 mm diameter, a 325 volts and a 572 grade 50 plate material with standard holes. F sub y is equal to 345.6 MPa. Minimum tensile strength F sub u is equal to 449.3 MPa. Allowable shearing stress F sub v is equal to 207 MPa for bolt threads included from shear plane. Diameter of hole is 3 mm bigger than bolt diameter. So, ang atong question sa kaning problem is number 1, determine the tensile capacity of the bearing type connection if the bolt threads are included from the shear plane. Number 2, determine the tensile capacity of the bearing type connection if the bolt thread are included in the shear plane. Allowable shear stress F sub b is equal to 145 MPa. Compute the theoretical length L if bolt threads are included from the shear plane. So, ang atong drawing guys is ang kani. Mo niyang top view and side view. Then, solution sa number 1. So, number 1 is tensile capacity if bolt threads are excluded from shear plane. So, first is net area of plates. So, A sub n or minimum net area is equal to 150 minus 2 times the quantity of 25 times 16. So, ang kaning 25 is actually gikan sa 22 mm diameter. But then, ang diameter of hole is 3 mm bigger than bolt diameter. So, plus 3 mong 25. The answer is 1,600 mm squared. Then, ang AE is equal to AN, so 1,600 mm. A sub G is ang gross area of a member at any point, which is determined by summoning the products of the thickness and the gross width. So, A sub G is equal to gross area lagi mo ng 150 times 16. So, we have an answer of 2,400 mm squared. Then, kaning T sub 0.60 F sub y A sub G o kani pong 0.50 F sub y o A sub E is actually gikan na sa NSCP specification. So, constant na siya. So, substitute na to sa 0.60 times A sub y times A sub G mo na ang atong nakabutan dire. Ang answer is 497,664 Newton. Then, dire pod sa 0.50 times F sub U, A sub E, ang atong answer is 359,440 Newton. Then, capacity of bolt in single shear. So, first things first is R times A sub V times A F sub V. So, pi over 4 times 22 raised to 2. A sub B is 207 MPa. Our answer is then sa number 2. Tensile capacity if bolt threads are included in shear plane. So, ang kalahian na ni sa number 1 o number 2 is included mas number 2. That's why ang ijang A sub G is 16 times 150 ang thickness o ang length. So, T is equal to 0.60 times F sub Y times A sub G. Then our answer is 497,664 Newton. Mo na atong gross area. Then sa usa pod 0.50 F sub u times A sub E. Substitute again. Our answer is 359,440 mo na atong net area. Newton gyapon na siya. Then same gyapon sa number 1 na magkuan gyapon ta sa capacity of bolt and shear. R is equal to A sub B times F sub B. Then substitute pi over 4 times 22 raised to 2 times 145 MPa. So ang kani is given na ni, mo nang gigiven sa number 2. That's why 145. Then our answer is R is equal to 55,109 Newton. Then T is equal to tensile capacity is 220,476. So times 4 gihapon na siya mong kanina ka map. Wala man nabutan. Then bearing capacity of bolt R is equal to A sub P times F sub P. So our answer is 189,784. So wala nang ibutang ng solution na kay same na po ni sa number 1. Same answer sa bearing capacity of bolt. Then tension ni ja is same gihapon mo nang 759,137. Then magpili gapon sa duha which is much lower kay para makakuanta sa safe capacity. So atong safe capacity is 220,476 Newton. Then sa minimum value of length. Number 3. Our length is equal to 2 times L sub E plus 75. So kan 75 nagapunin siya sa diagram sa 3.11. Then we don't know the value of L sub E, so we're gonna use its formula nga 2 times V over F sub U times T. Then ato sang pangitaon ng P kay wa tay nga ni nga value. So mao nang P is equal to 314,748 over 4. Mo na jang formula. So ang kanang babaw mao na ang sa number 1 nga excluded ang bolt threads. Then divided by 4 para ma-divide si Jaw from 1 bolt na naman. So mo yung value sa usa ka bolt. 78,687. Then substitute sa L sub E or sight distance mo na 2 times 78,687 over 449.3 times 16. Then L sub E is equal to 21.89 or shall I say 22 mm atong i-round off. Then natay value sa LA. So before ta mo atong i-substitute ni ja naman tay kuan sa minimum sight distance which is 1.5D or diameter of bolt. So mo nang minimum sight distance is equal to 1.5 times 22. Then our answer is 33 mm. So mo na atong minimum sight distance. Then atong substitute dire sa L sub E. So our answer is 141 mm. For problem number 2. A double lap splice connection shown in figure is made up of 6 mm by 150 mm and 9 mm by 150 mm. Use NSAP specifications and assume a double row of bolts with standard size holes for a bearing type connection with threads excluded from the shear planes. Minimum tensile strength F sub U is equal to 552.93 MPa. Assume diameter of hole is 3 mm bigger than the diameter of bolts. Allowable shear stress is F sub B is equal to 207 MPa. Allowable bearing stress is F sub P is equal to 1.2 F sub U. Diameter of bolts is 19 mm and F sub Y is equal to 449.25 MPa. Then the 3 questions. Compute And number 1 is compute the tensile capacity of the steel plates. Number 2 is compute the number of 19 mm diameter bolts to develop the full strength of the plates. Number 3 is compute the theoretical distance required. Capacity of steel plates. So bonus number 1. By inspection, the cross-sectional area of the epicenter plate is less than the sum of the areas of the two outer plates. Therefore, check the capacity of the center plate only. So center plate ra kibali ang kani, which is 9 mm ang atong gamiton. And solve sa AG or gross area. Then A sub n or net area is equal to 150 minus 22 times 2 times 9. The answer is 954 mm. Then getting the maximum net area. The formula for maximum net area is 0.85 times A sub g. Then the answer is 1147.5 mm squared. Then net area is equal to A sub e, which is 954 mm squared. Then atong siyang i-substitute dire sa tensile capacity equals 0.5 F sub u times A sub e. Then substitute, our answer is 263,748 Newton. Then sa tensile capacity nga 0.60 times F sub y times A sub g, our answer is 363,893 Newton. Then pagpilit na nga ni, which is the tensile capacity of plates. So atong gamiton is ang kani 263,748 Newton. Then sa number 2, number of bolts. Then ato pangitawon is ang maximum capacity of each bolt. Then by shear or double shear, R is equal to A sub V times F sub V is equal to pi over 4 times 19 squared more sa A sub B. Then F sub B, which is 207 times 2 tungod kay 2 volts man. Our answer is 117,381 Newton. Then by bearing of bolts, R is equal to 1.2 times F sub u times D times T, diameter and thickness. Substitute mo na 1.2 times 552.93 times 19 times 9. Our answer will be 113,461. Then magpili ta sa ni duha, which is ang mas gamay, mas lower. Our answer R would be 113,461 Newton. That will be our maximum capacity of bolts. Then getting the number of bolts, N is equal to T over R. So nalam tay T over R kibali ang maximum capacity of bolts, which is 113,461, ug ang atong kani tensile capacity, which is 263,748. Then our answer will be 2.32. The next is ang number 3 nga question. N distance required or L sub E. Muna ito pangitaon. Then to get the L sub E, use 4 bolts because there are 2 bolts in each row. Then P or load per bolt is equal to 2,603 times 263,748 over 4 tungod kay nagamit tag 4 bolts. Then ang kani, which is our tensile capacity. Our load per bolt is equal to 65,937 Newton. Then substitute to L sub E or P kibali sa L sub E. L sub B is equal to 2 times P, which is 65,937 Newton, over our F sub U will be 552.93 times the thickness, which is 9. Our L sub B is equal to 26.5 mm. Then getting the minimum edge distance, 1.5, which is the standard, times diameter of bolt. 1.5 times 19 is equal to 28.5 mm. Example problem number 3. A lap joint shown in figure 3.13 or ang kaning figure bolted with an 325 bolts having diameter of 20 mm and a 572 grade 50 plates material, 16 mm by 150 mm with standard holes. Assume diameter of holes is 3 mm larger than the bolt. F sub y is equal to 345.6 MPa. Then F sub u is equal to 449.3 MPa. Then F sub v is equal to 207.3 MPa for bearing type connection. F sub b is equal to 121 MPa for friction type connection. Then the question is, determine the tensile capacity of the plates if it is a bearing type connection. Determine the tensile capacity of the plates if it is a friction connection. Then lastly is, compute the minimum theoretical length of the lap if it is a friction type connection. So sa solution number 1, tensile capacity of the plates if it is a bearing type connection. The net area is equal to 150.2 times 25. So 25 again tungod kay ang atong diameter sa bolt is 22 mm plus 3 sa hole mo 25 times 16 ang thickness. Then our answer is 1,600 mm squared. Then getting the maximum net area, which is 0.55 times 150 times 16. Our maximum net area is 2,040 mm squared. Then A sub n is also equal to A sub e, which is 1,600 mm squared. Then tensile capacity is equal to 0.50 times F sub u times A sub e. Our tensile capacity is 359,440 Newton. Then tensile capacity 0.60 times F sub y times A sub g. Substitute sa atong mga given gipanghatag sa problem. 0.60 times 345.6 times 150 times 16. Our tensile capacity is 497,664 Newton. Then shear capacity of bolts. Dirita. Muna yung next nga solution sa number 1 to get the bearing type connection. R is equal to F sub u mu times A sub b is equal to 207.3 times pi over 4 times 22 raised to 2. Then our R is equal to 78,802 Newton. Then to get the tensile capacity of all the bolts, ato jang times anog 4, which is 315,208 Newton. Then getting the bearing capacity. Bearing capacity, R is equal to A sub P times F sub P, or 1.2 times D times T times F sub U. Then substitute 1.2 times 22 times 16 then times 449.3 mo na dyang value sa F sub U. Our R will be 189,784 Newton. Then times 4 again to get the bearing capacity of all bolts. So 759,137 Newton. Tensile capacity of the plate using a friction type connection. So ang procedure nga ni same gapos number 1 sa primero. Then net area is equal to 150 minus 2 times 25. So 25 tungod kay 22 plus 3 which is ang bolt o ang hole times 16. We have 1600 mm squared for atong net area. Then A sub n is equal to A sub e. So same sila value. Then atong ipang substitute diri sa tensile capacity which is 0.50 times 44.9 times 1600. Our tensile capacity is 359,440 Newton. Then diri pod sa same na sila sa number 1 og answer. Ang kalahian na nila kay atong igamit diri is ang friction in shear of rivets to get the tensile capacity or maximum tensile capacity. Shear of rivets is equal to R equals A sub V times F sub V. Then substitute mo ng pi over 4 times 22 raised to 2 times 121. So mo na yung value sa friction sa given. Then 45,996 Newton times 4 again tungod kay 4 volts. So our tensile capacity sa tanang bolts is 183,984 Newton. Then pangitaon na to ang mas gamay, so kani nga tensile capacity. Then sa number 3, finding the theoretical length of lap. So first is L sub E is equal to 2 times P over F sub U times T. So we have, so wamo tay value sa P mo nang atong pangitaon. P is equal to T over number of bolts. So P is equal to 183,984 over 4 which is 45,996 Newton. So nantay P atong i-substitute diri sa L sub B or edge distance. Edge distance is equal to 2 times 45,996 over 449.3 times 16. Our L sub B or edge distance from the edge kutob sa center sa bolt which is 13 mm. Then getting the minimum edge distance, so same ga po ng procedure sa line sa ubang problem, 1.5 which is the standard times diameter of bolt. So ang atong diameter of bolt is 22 man, so our minimum edge distance is 33 mm. Then S is equal to 2P over F sub U times T plus D over 2. So substitute, then mo na itong procedure ibalik pag substitute. 2 times 45,996 over 449.3 times 16 plus 22 over 2. Then RS will be 23 mm which is lesser than 3 times diameter of bolt. So to get the length S length of lap, S is equal to 3 times 22 which is 66. Then atong substitute there is a length. L is equal to S plus 2 times L sub E. Then our length will be 132 mm. That's all.